Hello Year 9. I'm going to talk you through some of the dangers of radiation and radioactivity. Okay, so we're going to think about some of the problems that are associated with two ideas. One is contamination, okay, which is probably a word that you've come across before, and the second is irradiation. Okay, so just as a little recap, there are some questions here, okay, for you to pause the video and have a go at, and I will give you the answers in a second. Okay, so these are the answers for you to check. Okay, you need to be familiar particularly with the difference between the radioactivity in question number 1. Okay, I haven't had many pieces of work in with these equations. Okay, so if you've struggled with it, you need to let me know so I can give you a bit more help and a bit more practice. Okay, so really question 1, 2 and 3 are key ideas that you need to be able to do. Okay, so question 1, 2 and 3 are really, really essential. Right, okay, so there's two different ways that radioactivity can be hazardous. Okay, so the first way is contamination. So contamination is the presence of materials that contain radioactive atoms on something else. Okay, so the problem with this is that the decay of the atoms can cause what we call ionization. Okay, so remember that some of this radioactivity can knock an electron out of the shell of an atom and turn it into an ion, okay, which is potentially hazardous. Now there's different risks associated with the contamination. It depends on what type of radiation you've got and the actual amount that you're exposed to, okay, but it's not always bad. Contamination can actually be quite useful. So one of the ways that you can get it is if you touch or handle radioactive substances without taking precautions. Now in this case you can see that the guy's got the mask on, he's got his hazmat suit on, he's using gloves, everything's labelled with warning signs to make sure that people know what's there. Okay, but contamination is when particles get onto or into an object. Okay, so it could be that it gets onto your skin, that would be included in contamination, or that it goes inside your body. Okay, that would also be contamination. Now, quite often there's a lot of misunderstandings and people think that, you know, well, if you touch something radioactive, then, you know, with the Marvel comics you become the Hulk, or you become Spider-Man, or you become some sort of superhero. Okay, you don't, right? So, but there are hazards associated with it. So radioactive sources do have hazards, but you're not going to develop superhero powers. Okay, so if you touch something that is radioactive, then you would become contaminated because it would remain on your skin, or potentially it can get inside your body. Okay, so it's this idea of unwanted atoms get onto your onto an object. It doesn't have to be you, it could be clothing that you wear. Okay, so contamination is this presence of these radioactive atoms. Okay, now one of the problems is that they could cause you harm because they ionize your cells. Okay, so it's not just that they knock out an electron from an atom, they will also do the same to your cells, which can then kill your cells. Okay, and that's where it can cause you harm. Okay, so it can actually cause electrons to be knocked off the atoms in your DNA, which will potentially either kill or damage your cells. Okay, not a good thing. Now, if your DNA gets changed, it can lead to mutations of that DNA. Remember, DNA is the instructions that is carried in every single cell in your body that gives your body the instructions of how your body works. Okay, and if you mess up the code for the DNA, then you cause a mutation, and that can ultimately lead to cancer. Okay, so contamination is particularly dangerous when they get inside your body. Now it depends on which type of radioactivity and where it gets as to how much harm it can cause. Okay, so remember we've got our 3 different types. We've got alpha, beta and gamma. Alpha is the biggest particle. Okay, so that is the most ionizing. Now, on the outside of your body, because alpha particles can't travel very far, that means that they wouldn't go through your skin. So if you had an alpha particle on your skin, you'd be be treated or you'd be dealt with in terms of getting rid of that alpha particle, but it's not going to cause you a big problem. However, if that alpha particle got inside your body, then it would cause massive problems. It would bounce around like a pinball in a pinball machine, and it would ionise your cells. Okay, so all of these different types, alpha, beta and gamma can cause ionisation. Okay, alpha particularly so if it gets inside your body. Okay, so like we said, it can ionise your cells, it causes these mutations in your DNA, and then that will either kill the cell or cause it to become cancerous. Cancer is just uncontrolled growth, okay, of cells. So the cells, rather than multiplying in a nice controlled way, they multiply completely out of control, and that is what would cause a tumour. Okay, so this is how radioactivity can cause cancer. Now, like we said, alpha particles on the outside of your body aren't a huge problem. They wouldn't do much harm. But if they get inside your body, then they are very, very dangerous. Okay, and I'll give you an example of somebody who had that in a second. Now, beta, it's more penetrating, but it's not as ionising. Okay, so it might be that beta particles can pass through your body. However, they wouldn't have as much of an impact on the cells as they pass through. Okay, so beta particles, they're not absorbed as strongly, but they can penetrate into your body. Okay, so you've got the two different flip sides of this that we need to think about. Now, gamma rays, we know that they're very, very penetrating. On that diagram that we looked at last week, we know that they can go all the way through paper, through aluminium, through thin pieces of lead. Gamma is very, very penetrating. However, they're not very ionising. But because they've got so much energy, they can cause lots of hazards. Okay, so this is talking about contamination still. Okay, so there's a summary here, and the impact that the radioactivity will have depends on what the source is, how much you get, and whether it's inside or outside your body. Okay, so like we said there, alpha radiation is very dangerous inside your body. Beta is dangerous, but not as much. And gamma is dangerous, but again, not as much. Outside the body, the alpha particles really can't do very much. The beta particles, they are more dangerous because they can penetrate into your body, and the gamma will go straight through you. Okay, so there's no getting away from it. So you're more likely to have contamination from that point of view. Okay, so again, I've got another sort of summary really. Alpha will be stopped by your skin, but it's more dangerous inside your body because it ionises your cells. The beta will go through you, okay, so it's more dangerous outside, and the gamma will go straight through you, okay. And like we said, it's this whole idea of ionising the cells, okay, which cause them to be either kill the cell itself or to mutate them and cause cancer, or something like leukemia, which is cancer of your blood. Okay, so this in turn is just an animation showing you how cancer potentially could be caused. So you've got this mutation in your DNA structure and the instructions, and rather than the cell copying in a nice controlled way, saying, right, I need to split into two and that's perfect, it just grows out of control, okay, and that's what becomes a tumour, and it could be on your skin, it could be inside your body, it could be anywhere, okay. So that's what cancer is, and this radioactivity can cause that. Okay, so this is the example that I was talking about. Alexander Litvinenko, can't really pronounce Russian, was a Russian spy, and he was living in the UK. He was living in London, and in 2006 he was poisoned with polonium. Okay, and polonium is a radioactive material that will give off alpha particles, and it was actually put into some orange juice that he drank. So within a very, very short space of time, his cells became ionised, and he died from radiation sickness. So he was poisoned on the 1st of November, and by the 23rd of November, he died. Okay, so inside your body, it's really, really dangerous. Now, the other idea is this idea of irradiation. Okay, so irradiation is when radioactivity is like objects are exposed to radiation. Okay. So like if you shine a torch onto your hand lights up, or it looks like it's lit up. It doesn't actually go through it, but it looks like it's lit up because your hand has been exposed to the light. So irradiation is when you are exposed to radioactive sources. It can cause damage, but it can also be used in good ways, and we'll talk about the uses tomorrow. So just in terms of comparing the two, a lot of the food that you eat will have been irradiated. So for example, strawberries, if you've ever grown strawberries and you pick them at home, they don't last very long. When you buy them in the supermarket, they will last a little bit longer, and the reason for that is because they are passed under a source of gamma radiation, and what that does is it passes straight through the strawberries. Any bacteria that are on the surface of the strawberry are killed. Okay, so basically it preserves the strawberries and make it last even longer. Okay, so this is one way that irradiation is used. So soft fruits, anything that rots very quickly, can be irradiated using radioactive sources. So radioactive means that it's got this substance that's got radioactive particles in it. If it's unintentional, so if it's unwanted, then it's contamination. Okay, irradiation tends to be purposeful. So you've got a comparison here of the two ideas. So irradiation is when it's exposed to a source outside of the object. We can be irradiated, okay, so I can be exposed on the outside of my body. It doesn't cause the object to become radioactive, okay, so in most cases it just goes straight through it, and it can be blocked. Okay, so if you go for an X-ray, for example, that is potentially hazardous, but they will use shielding to prevent you being damaged. Okay, and irradiation, as soon as the source is removed, that irradiation is also removed. Contamination is when the actual source itself is on or inside an object, so it's either on my skin or it's inside my body, and the contaminated object will be radioactive, so I will become radioactive for as long as that source is on my body or inside my body. Once it's contaminated, the radiation can't be blocked from it, and it's very difficult to remove all of the contamination. Okay, so this is why we need to be very, very careful when using radioactive sources, and we'll talk about that again tomorrow. Okay, so there's a sheet on class charts that is comparing irradiation and contamination. At the moment, I've made them all sound really, really bad, but tomorrow we'll look at the useful ideas of both irradiation and contamination.